Now we have single displacement reaction. What are displacement reaction? The chemical reaction in which the more reactive element displaces less reactive element from the compound are called displacement reaction. Let's see the examples of displacement reaction. Zinc when reacts with copper sulfate solution. Here zinc is more reactive than copper. So this zinc displaces this copper from copper sulfate solution. Because the position of zinc is higher than the position of copper in the electrochemical series. Here S represents solid and AQ represents aqueous. Aqueous means the solution of water. Now, let's see another example. When zinc reacts with dilute sulfuric acid, this zinc displaces this hydrogen. When hydrogen gas is evolved, this zinc itself combines with sulfate. So zinc sulfate is formed. Both the valency of zinc and sulfate is 2. On interchanging their valency, so the molecular formula of zinc sulfate is ZnSO4. Next, number 4, double displacement reaction. Double displacement reaction is also known as double decomposition reaction or precipitation reaction. Now, what are double decomposition reaction? The chemical reaction in which two salt solutions are mixed. They exchange their radicals with each other and give an insoluble solid in the form of precipitate. That is why it is also known as precipitation reaction. Let's see the examples of precipitation reaction or double decomposition reaction or double displacement reaction. Here silver nitrate solution. This silver nitrate solution is used for the analysis of chloride ions or chloride salt. Whenever this silver nitrate solution reacts with chloride salt or dilute hydrochloric acid, it gives white precipitate of silver chloride in the form of precipitate. Here example silver nitrate solution when it reacts with sodium chloride, here sodium chloride, chloride salt. So here silver nitrate and sodium chloride, they exchange their radical with each other. Here silver is basic radical, combines with the acidic radical of sodium chloride, that is combines with chloride. So it gives white precipitate of silver chloride, AgCl. Both the valency of silver and chloride is 1, so its molecular formula is AgCl. Here chloride, here sodium combines with nitrate of this silver nitrate. So it gives sodium nitrate, NaNO3. Both the valency of sodium and nitrate is 1. So the molecular formula is NaNO3. Let's see the another example here. Barium chloride solution. This salt solution is used for the analysis of sulfate ions or sulfate salt, or whenever this barium chloride solution reacts with sulfate salt or dilute sulfuric acid, it gives white precipitate of barium sulfate. Here example, barium chloride solution when it reacts with dilute sulfuric acid, they exchange their radical with each other. Here barium chloride basic radical combines with acidic radical of the this dilute sulfuric acid, that is sulfate, and it gives white precipitate of barium sulfate, BaSO4. Both the valency of barium and sulfate is 2. On interchanging their valency, 2 cancel, so its molecular formula is BaSO4. Here hydrogen combines with chloride of barium chloride and gives hydrochloric acid, that is HCl. Both the valency of hydrogen and chloride is 1. So the molecular formula is HCl. Now next we have oxidation and reduction reaction. A chemical reaction which involves addition of oxygen is known as oxidation reaction. A chemical reaction which involves removal of oxygen is known as reduction reaction. Oxidation reaction also defined as removal of hydrogen from the substance. Reduction reaction is also defined as addition of hydrogen to the substance. So, substances which oxidize other substances are known as oxidizing agent. Substances which reduce other substances are called reducing agent. And every chemical reaction involves oxidation and reduction reaction. Let's see the example here. Copper oxide, which is black in color, both the valency of copper and oxide is 2. On interchanging their valency, the molecular formula is CuO, copper oxide, which is black in color. When hydrogen gas is passed through this copper oxide, this black color disappears and reddish brown copper is formed. Here in this reaction, hydrogen reduces this copper oxide to copper. Here that means copper oxide reduces to form copper by the loss of oxygen, whereas hydrogen is oxidized to oxidized to form water molecule by the addition of oxygen. Dear children, here we come to the end of today's online class. Please go through this video clip. This will help you to understand your lesson. Thank you very much.